In this video, we're going to solve a problem involving sequences. We're going to form and solve an equation. Now we're told here are the first 5 terms of an arithmetic sequence. Arithmetic sequence, by the way, just means that we're adding or subtracting the same number each time to get from one term to the next term of the sequence. So in this particular sequence, we can see we're adding 4 each time. And it says the nth term of a different sequence is 3n plus 18. And the last term of each sequence is the same number, and the same number of terms in each sequence. So it's saying there's some particular n, which is, say, the last term of the sequence, the nth term, where those 2 terms are the same. So the nth term of one sequence is the same as the nth term of the other sequence for a particular value of n. And we need to find out what that value of n is, how many terms are in each sequence. So let's first try and find the nth term formula for this sequence here. Now, how do we do it? If I just copy this out, what you first do is you see what the difference is, the common difference, as we call it. And we saw that we're adding 4 each time. Now, if we're adding 4 each time, then we can start the formula as 4n. So remember, we take that number and we put it in front of an n. Now, the nth term of our formula was 4n. What would be each term of this formula? Well, the first term, that's where n is 1, would be 4 times 1, which is 4. The second term, where n is 2, would be 4n, 4 times 2, which is 8. The third term would be 12. The fourth term would be 16, etc. But we don't want 4, 8, 12, 16. We want 7, 11, 15, 19. So what adjustment is required? Well, if our sequence is starting like that, we need to be 3 bigger to correct it. So the 4 needs to go to 7, the 8 needs to be correct to get to 11, etc. So therefore, the formula would be 4n plus 3. And that would then work, because if we add 3 to that sequence above, we get 7, 11, 15, etc., which is the correct sequence. So, okay, we've got the nth term formula of this first sequence is 4n plus 3. And the nth term formula of the other sequence is 3n plus 18. And we're saying for some particular n, the 2 terms are the same of each sequence. So we're going to set the 3n plus 18 to be equal to that 4n plus 3, because we're saying those nth terms are the same for the 2 formulas for a particular value of n. Now we need to solve this equation. Now there's more n's on the right-hand side than the left-hand side, so we want to get the n's on the right-hand side. So to get rid of that 3n, I subtract 3n from both sides. That just leaves 18 here, and 4n minus 3n is n. And then to get rid of that plus 3, I just subtract 3 from both sides. 18 minus 3 is 15, and then we're just left with n. So n is 15, so that's basically saying the 15th term of each of those sequences is the same. And that is the number of terms in each sequence is 15, because the last term, the 15th term, is the same. And that is the final answer.